A very good morning to all the distinguished dignitaries, respected professor, ladies and gentlemen. At the outset, I, Ananya Sanjeev, and Vaibhav Bandari on behalf of Department of Electronics and Communication Engineering, Amity School of Engineering and Technology, Amity University, feel honored to welcome you all on the first day of the 12th International Signal Processing and Integrated Network Conference, SPIN 2025. As one of the leading global universities, Amity University is dedicated to its responsibility of imparting its students a strong foundation and a platform for empirical inquisition. With this agenda, SPIN 2025 intends to bring together professionals, academicians, industry experts, researchers, and enthusiasts to discuss various emerging trends and innovations, share research results, and new directions in the field of next generation technology. It is a great privilege and honor to have amongst us Dr. Matti Latva Aho. I would like to call upon Dr. Nidhi Gaur to present a sapling to Dr. Matti Latva Aho. I would like to call upon Dr. Ashwini Kumar Dubey sir to present a sapling to Dr. Matti Latva Aho. Thank you, sir.
A brief introduction about our esteemed speaker. Dr. Matti Latva Aho is a distinguished expert in wireless communications, holding MSc, LIC Tech, and Dr. Tech degrees in electrical engineering from the University of Oulu, Finland, awarded in 1992, 96, and 98, respectively. From 1992 to 1993, he worked as a research engineer at Nokia Mobile Phones in Oulu. Before joining the Center for Wireless Communication at the University of Oulu, Professor Latva Aho served as the director of CWC from 1998 to 2006 and later as head of the Department of Communication Engineering until August 2014. Currently, he is a professor of wireless communications at the University of Oulu and served as the director of the National 6G Flagship Program. He is also a global fellow at the University of Tokyo, reflecting his international recognition in the field. With an extensive portfolio of over 600 conference and journal publications, Professor Latva Aho has significantly advanced the field of wireless communications. His contributions were recognized in 2015 when he received the prestigious Nokia Foundation Award for his groundbreaking research in mobile communications. Welcome once again, sir. We are honored to have you grace SPIN 2025.
Thank you. Thank you for your nice words. Thank you, Dr. Dubey, for inviting me here. So, I'm coming from Finland, Oulu. Oulu is very northern city. We are only 175 kilometers south of Arctic Circle. So we are very northern city. Oulu is really strange city as well. It is very important in Finnish ICT technology development. The population of the city is about 250,000 people only, but still it's one of the, if not the most important technology hubs in our country. The last standing Nokia factory in whole Europe is in our city. And they are right now building and expanding their new R&D center in right next to our university. I'm going to talk to you about interrelation of sustainability, resilience, and efficiency of future 6G systems, and trying to highlight why it's important to have a broader look to 6G development rather than only technology advancements, which is also my daily job. My students are pursuing their thesis works and PhD thesis on very sophisticated, deep tech questions, publishing their papers in IEEE transaction journals mainly. But they are not considering about these broader perspectives either, but we have to talk about this for specific reasons. Our 6G flagship program was started already May 2018. It's 4+4 year government funding, which will expire next year, June. And because we expect and want to continue the program to next phases, we have started to talk about and discuss internally what justifies our next steps in our 6G journey. In our research, we have been trying all the time from the very beginning. This is our, let's say, research palette that we defined already in 2017 when we were planning the program, that we want to carry out besides technology research. We want to be strongly thinking and developing future business models that are enabled by wireless technologies. What other we can have besides these mobile network operators, and what justifies them, and what technical requirements and what regulatory changes those would demand to make happening. So regulation is part of our research agenda as well. We are official member of our national delegate in ITUR, Working Party 5D working group, defining 6G requirements. Sustainability, without saying, is very important, and technology is one of the most, if not the most powerful tool to solve some of the sustainability challenges that the globe is facing. How can we save the planet? Technology has the answers to it. In our flagship, we have 4 strategic research areas that we are covering. Wireless connectivity solutions is looking at radio access network technologies, transceiver algorithms, and how we make these 6G network concepts happening, putting everything together. That's the biggest research area. That's also my personal area, which I'm leading in the flagship, besides being director for it. Second is device and circuit technologies. That is looking at how can we build the future radios, in particular at high spectrum bands, going beyond millimeter waves towards sub-terahertz spectrum bands. And our researchers and professors are looking at IC technology challenges. They have already implemented transceiver chip in few phases at 300 gigahertz frequency band. Then the third one is intelligent computing in wireless networks. How can we distribute computing tasks in the network, and how can we take advantage of distribution of both users and base stations in collecting a lot of different type of data to come up with much smarter algorithms and solutions. Mobile edge computing is one thing that we are pushing forward. Then the fourth one is applications and services. There we are looking at different vertical areas, vertical application areas, their specific needs. We have developed since 2015 a test network environment, which we can use in demonstrating capabilities of future mobile networks for different applications. So our vertical application areas that we are looking at are health, industry, vehicular, energy, and security and defense segments. These all are critical parts of national infrastructures anywhere. That's why we chose them. Global collaboration has been very important from the very beginning, and there's also a flag of India as our strategic partners. We have had various different collaborations between different Indian institutions, and also have MOU made with, for example, Bharat 6G Alliance. So we started to develop our 5G test network already in 2015 and showcased it at Pyeongchang Winter Olympics in Korea 2018, and have been developing it ever since. There are lots of different things that have taken place on the way. It's part of this European-wide research infrastructure roadmap. We are part of national infrastructure funding scheme, and were entitled a few weeks ago a special status, so that they are committed to keep funding our infrastructure development for years to come. Towards the future, we are adding more and more programmability capabilities and software-defined networking ideas to this network. And we have all these latest 5G base station products that Nokia have been able to provide to us. And we have our own SIM cards, we have spectrum licenses to operate. And so we are a fully functional mobile operator in our campus. So far, the results are quite good in academic sense. Almost 4,000 peer-reviewed publications. This is made by almost 600 researchers that we have at our university participating in this program on those four strategic areas I mentioned. Lots of different projects, lots of social media events, and we, for example, generated more than a dozen, maybe 13 is the right number, 6G white papers that are available at our website. They have been downloaded over 1 million times through internet. So if the students are keen on learning what is critical to know about future 6G technologies, etc., go and check our white papers. They are freely available and are not that deep technical to read. Okay, so like I said, our program is ending, the funding term is ending next year. That's why we started to discuss about how to continue. We know the story how different generations have been telling or aiming at. The left-hand side is the 4G vision stated within Europe by European Commission. ABC, always best connected. So heterogeneous networking and smoothly changing from one network to another one when users are moving around. So that was the vision then. Then when 5G was being developed, the vision was that Internet of Things, and we want to connect lots of different things other than humans to be part of future mobile network. So this machine type communications, critical communications, and IoT came into play when developing that. With 6G, if I have to pick one target for it, it has been 6G metaverse or 6G enabled metaverse and massive digital twinning that has been driving so far the discussions and research. Beyond these things, we started to think what is missing. Resiliency, sustainability have not been discussed seriously enough. AI will start to drive lots of different things in society, much more, and not only in good ways always. So we have to be a little bit critical as well, so that it's not misused against humans. So AI will be there for sure, and its role is increasing every day. So these are probably the next things that we have to also focus our efforts. So why should we care about resilience? First of all, climate change is causing lots of more frequent natural disasters everywhere in the world. They take different forms. And when this event happens, Also, the critical infrastructure falls apart if we don't take care of it, or if we are not prepared for it. So what different critical infrastructures are also interconnected, and there's a chain reaction of failures when massive natural disaster takes place. Also, cybersecurity attacks are more and more common, of different forms. Of course, mobile networks are pretty well protected so far, but that's not necessarily the case. When we move to software-defined networking, we talk about open RAN type of things, etc., etc. So new players are entering, providing overall solutions. Currently, the situation is more like that one vendor provides the whole network solution. In the future, one scenario is that tens or even hundreds of different vendors can be providing software modules doing something particular in the future network. How can we really trust that there's nothing serious embedded in that will be working against the end users? Then, of course, the most extreme thing is hybrid threats. This is reality in Europe today. Let me give you an example from my country, Finland. During the past year, we have had 5 episodes in the Baltic Sea area where the undersea cables were cut by commercial vessels. It cannot be coincidence or accident, so it's somehow organized. So they are destroying the communication infrastructure momentarily. Also, this hybrid warfare takes place in many forms, and we are right next to neighbor to Russia, for example, and unfortunately they are jamming our GPS connectivity, and it's unfortunately only a matter of time when something really bad will happen. The commercial aircraft will crash or something like that. So we are being attacked, that's a fact. But that's why, in our opinion, we have to be much better prepared for that, also when we talk about 6G networks in the future. So the critical drivers to 6G and beyond, we may think of several different things. There are societal, business, standards, and technology-driven issues that we can consider and look at what are very important. If we start from technology, and if really the vision is that we try to connect everything and everywhere to be part of future networks, is from these tiny IoT devices which can be embedded to anywhere, and so there's a possibility that a lot of data is collected from end users, from their critical functionalities, whatever these users are. So the data privacy and security is becoming much more important. And it's actually could be a showstopper to not to enable this widespread IoT explosion in the future. Then another thing, service-driven network architecture. I think in the future, if we put the future a little bit far enough, this role of access network technologies will be diminishing. So do we care if we access our services through Wi-Fi network, cellular network, or something else? We just need to access the services. So this vision of 4G is not yet implemented, always best connected, but it will when time goes on. So this service-driven network architecture means basically that there are different providers for services and access possibilities, and they differentiate a lot. In Amity campus, it can be very different to Indira Gandhi Airport. Somebody has incentive to build the networks and create services for particular needs at that specific location. So users who are given access to that local service base can access highly different services depending on what they are doing where they are. So services are driving the future if the future is put far enough. Maybe not yet at 6G, but eventually yes. Super efficient connectivity. We have been investigating sub-terahertz radio technologies for some years now, and are aware of the implementational bottlenecks, what needs to be improved and how to solve the problems. Commercially, they are not yet mature enough to be deployed in the first phase of 6G. And also industry is not keen to move to that immediately because it's too big of a change, in their opinion, in terms of radio technology. And they are afraid of the fact that the chips would not be available by chip vendors. This is what has happened a little bit already with millimeter wave chips, that there are not enough different providers providing the chips. So when we go to this above 100 gigahertz spectrum, we have huge amount of bandwidth available, enabling huge data rates per connection. Of course, when we go to higher in spectrum in transmission, the propagation loss is becoming higher and the radio ranges are dropping. But we can offer services in local areas like one room, one corridor, using these spectrum bands, and then we can have really high capacity systems. Artificial intelligence and machine learning can be used to improve networks operations, to optimize the networks automated fashion, and also to utilize the wireless networks because they are distributed, to come up with much smarter applications, smarter than we can even imagine today. Currently, the AI computing and for example, ChatGPT type of LLM systems, they require centralized cloud processing. What if we can distribute some of the processing to local clusters to have more local information, what is locally relevant, and maybe in future also, which could be more dynamically responding to what is happening around, like in some traffic usage scenarios would be really useful. So wireless networks can be really heavily utilized to improve experience of all kinds of AI applications. Then if we go back to the top standards, global collaboration is very important in standards development. The 3GPP RAN group meeting takes place in a few weeks' time in Korea, and they start to get organized, and then we will learn much more how they plan to carry out 6G standardization development. And lots of things will start to happen this year. In the summertime, ITUR is releasing 6G technical requirement specification, where they are saying what is the transmission rate, what is the reliability, what is the user density, outages, whatever needs to be defined. Also, there will be new definitions related to AI, hopefully also for resilience, as we are trying to suggest them to look at that more seriously. So far, it looks like global standard will be possible in 6G. Although sometimes there is some suspicion that what will China do? Will they do something on their own? Are they joining the global 6G standardization or not? So far, it looks like everybody would like to have a global 6G standard, because with global standard you have global market as well, and you have the big volumes of producing, for example, these important radio chips, so that the price can go down. Business. I think we need something else besides current mobile network operators. We have been developing what we call local operator model, which requires that you have rights to use the spectrum. So spectrum regulation needs to be changed. And this has actually been already deployed in 5G, in private 5G networks. For example, in Japan and Germany, and they have specific spectrum bands for local private 5G deployments. And those are meant primarily, I think, primarily for industrial use cases, so that factories can develop the efficient 5G networks for their own needs and tailor the capabilities of the network for it. I think in the future we need to have differentiated different solution bases depending on where we are. Hospital, campus, airport, downtown, vehicular settings, sports arenas, all are very specific, and they have specific interesting services that they should develop. And also when you look at the technical details of what they need for making these services available, they are different. They are not the same. We are not only offering bit pipe solution, but we need something which is tailor-made, customized for different locations. And we have so many different application areas, from health to agriculture, energy, traffic, automotive, so that these will enable totally new ecosystems, value generation mechanisms, and I think operators are too fast to move with that. We need more fast-moving investors and technology developers to make those things happen. And then we can scale globally, because we have very similar setting in agriculture in different countries, for example. And in almost every vertical, you can scale it in different countries. Then let's go to the first one, digital inclusion. Digital inclusion is really important, since we rely more and more on different types of mobile services, independently where we are located. Are we in rural area, urban area, wherever we are? We really depend on being able to use mobile services and to have mobile broadband connection. It's not, coverage is not uniform, and there are lots of coverage challenges in every single nation, and they are different, of course, depending on the country. And many of the challenges are related also to economical facts. And of course, good example of how economy can really boost coverage challenges is what Jio did in India. Very short time they built countrywide 5G networks, and India is now really can be said to be leading 5G nation. Remote areas connectivity has also technical aspects into it. Of course, we can always think that let's use satellite connectivity, and let's try to integrate satellite and mobile cellular to harmonize the concept, so that with one terminal we can use them both. There are some attempts already to do that. Some high-end iPhone and Samsung phones, they do support Elon Musk's Starlink connectivity, but only sending text messages, because of the signal is so weak that you cannot really expect to have any broadband data connectivity, but maybe that can be fixed. But remote area solutions, there are many more. We can try to tune existing mobile cellular radios in different ways to extend the coverage by introducing relay stations. That has been discussed for a very long time. By introducing these reflective intelligent services, which has been a hot topic in research community for some years already. There are many different things we can do. And I think these remote areas coverage challenges need to be tackled. I think it's of everybody's interest. That one is, by the way, also related to the resilience. And we have to improve resilience of nation, resilience of mobile networks. Part of the resilience is that people have communication channels functioning, very important feature. But also the networks themselves have to be resilient, robust against external attacks. What can we do? to improve that? Big challenge. I'll skip a few of the slides. So in general, I think when we start to look at these very high level targets for future wireless networks, we have sustainability targets and challenges. Of course, in sustainability, we have technical issues, societal issues, economical, environmental issues related to sustainability challenges. Efficiency, of course, we know efficiency means different things. How to make them technically better performing, better serving the end users. Also, energy efficiency is between this sustainability and efficiency in this broader borderline. Then the third one is this resilience. How can we make the networks robust against disturbances? These are all interrelated, and of course we have to also understand that whatever solution is finally made, it's always a compromise. One misconception is that sometimes people say that isn't resilience part of sustainability development targets? No. Sustainability development is very long-term process. That's the ultimate goal, really to be sustainable so that we preserve nature and planet. Resilience, on the other hand, requires really fast adaptation when something unexpected happens. But we have to very quickly tune the network to work in a more robust mode and then gradually return back to the normal operation. But the problem is that these bad things don't happen frequently. We never know when they are happening, when part of the network is totally broken or when energy grid disappears. So is it worth really investing money to make networks more robust against these disturbances? That is a big question. Who is willing to invest to make it happen? Efficiency, simplistically said, can be improved by having more spectrum, improving the spectrum efficiency, typically with all kinds of really great signal processing algorithms that improve the transmission capacity of each link. The third one is spatial splitting, so forcing the coverage of each base station to be much smaller so that we can reuse the same spectrum over and over again, and in that way increasing the capacity. So these are really the basic tools to improve capacity. The next question is how to take this resilience challenge to be part of 6G requirements. There's already one ITUT recommendation, which is 20 years old, where they have defined different network recovery parameters. Maybe we should look at what they have defined and try to look at the target values for those in 6G requirements. In the USA, they have already adopted what is called mandatory disaster response initiative a couple of years ago, 2-3 years ago, by FCC, where they force US-based mobile network operators to collaborate in the event of some anomalies happening. So they force national roaming, for example, when one network is down for whatever reason. This is one positive indication that different countries are reacting already to improve resilience. Another one is that in 5G, 3GPP with standardization, there has been study item mission critical communication features where they are already introducing device-to-device connectivity, push-to-talk, and replacing a base station pretty fast if it's disappearing. So this development is for sure going forward. So these critical communication applications are driving this. And one of the key vertical applications which is driving this is train communication systems, which and they try to have the train control systems implemented by using 5G technologies. So there are lots of different questions that we can look at. Technological issues raising different questions. Is this time for integrating satellite and mobile cellular? Interdependencies of critical infrastructures, looking at how we can tolerate power grid failures. How should we deploy battery backup systems more systematic way? And how to utilize renewable energy sources to improve the continuum of power generation. Softwareization, I already mentioned that there are new supply chains with unknown providers, and that is an issue that has to be considered. Standardization and regulation, these things need to be raised in standardization process. They have to respond to this request, but the request has to come from different delegates participating to ITU work and 3GPP work. And Finland has raised this in ITU work already, that this has to be addressed. Then the business considerations are, what is the business model justifying all the investments? How can we make it happening? The fact is that these resiliency issues are not currently discussed strongly enough, and we still have some time and possibilities in bringing this to spotlight so that they have to at least discuss this matter when they start to define requirements and finally the standard making 6G. If you are interested in finding more of what we are doing, there are different social media channels that you can take a look. We also organize every year EU CNC 6G Summit in collaboration with European Commission. This year it's in Poland. Unfortunately, submission has already ended to that. So with these words, thank you for your attention.
So my question is pretty simple. So one day the 6G technology will definitely be deployed. So my question is how the regulatory bodies are going to make the guidelines for this 6G technology so that it cannot be used for the wrong purposes. Yeah, that's
how it cannot be used for wrong purposes.
Yeah.
I think that's not part of the standardization. That's not the idea of standardization. Spectrum regulation defines very clearly for what purpose the spectrum is given, and national regulators are following that it's used exactly for that purpose, and they are following all the ethical rules and real rules for what it should be used. So I think it's national matter, not a standardization issue at all. Standard is enabler. And when it enables things, then nationally we can implement different features of it, depending on our national needs. But maybe there will be some things, actually in Europe it's quite heavily discussed. That, for example, whenever we utilize AI or new technologies, there are lots of discussions and rulings what not to do. And Europe is very good at telling that what not to do, and it's slowing down the development. But maybe it's a smart thing to do anyways in the end.
So my question is that a term you have mentioned, that reflective intelligence services in remote area connectivity. Will you please explain that?
So these reflective intelligence services can be implemented in many different ways, and there are lots of research and ideas behind it. That they are considering these metamaterials to be used in these services. Actually, it's multi-antenna array, can be passive or active depending on what you want to achieve. and it reflects the directed. If you have a beamformer somewhere, you beam the radio transmission to certain direction, and you know that there is this intelligent reflector, and it reflects the signal, let's say, behind the obstacle. So there's a big obstacle, and you're going around the obstacle by deploying that. And then you can, for example, double the range.
Okay, so
in the best case.
AI techniques are using in that
Huh?
question? Any AI techniques are using in that thing?
Is there something where AI is not used? Yes, of course. AI and ML algorithms are of course, one of the areas that researchers are looking at. Because you have to learn the channel characteristics. You have to know the channel parameters, and there are many ways to find that out.
Thank you.
So my question is, with advancement in wireless communication, concerns have been raised about potential effects of electromagnetic waves on wildlife. How might the electromagnetic waves used in 6G networks impact the bird populations and the behavior?
Can you relay that message to me, Dubey? I couldn't hear much. So what was the question?
Sir, how might the electromagnetic waves used in 6G networks impact the bird populations? As with the advancement of wireless connections, concerns have been raised about the potential effects of electromagnetic waves.
I really cannot decode your message. Okay, right. So the radio transmission emission limits are heavily regulated. This and these really carefully have to be followed by every single radio transceiver. The only exception is that, and of course, for the purpose for what it's meant to be used, so like handheld mobile or whatever. But base station transmitters, they have several tens of watts of transmission power, and so the effective radiated power is really, really high and strong in the vicinity of a beamformer antenna. So if you go and if you, for example, are using millimeter waves in the future, if you go right next to the base station antenna and watch that antenna, it burns your eyes for sure. So it's not healthy for human beings, but that's not the case how it's meant to be used for humans. But of course, if birds sits there and watches that, it's not good for birds' eyes either. So of course it has impacts. But we don't see any major challenges compared to whatever we have been using beforehand. There's always these groups of people machinated by different motives, I don't know always what, who are trying to say that mobile wireless systems are really harmful to human health. I would say something opposite. I think it has been helping our mental status a lot, improving our social networking so much that even if there would be a small issue to our health, but mental health has improved a lot. And there's no way avoiding using mobile phones in the future either. But in the future developments, high frequencies, that is of course all the time studied, and we don't see any major challenges compared to what we have had so far as a discussion topic.
Yeah, so thank you so much, everyone. I know that you might be having more curiosity, and you can forward those questions to me, what is coming in your mind. I will definitely forward to Professor Matti, and he will be happy to respond to you. Okay, so it would be a great pleasure. Thank you.
Now may I invite Dr. Ashwini Kumar Dubey to present a certificate to our esteemed speaker, Dr. Matti Latva Aho, as a token of gratitude.
Yeah, we have to.
Now I would like everyone to move to 102A, F2 101A for further paper presentations. Thank you.